Today, we're rediving into a hot-button topic that has been making waves across global defense circles. The recent claims about an Iranian missile purportedly ramming into an Israeli intelligence chief's safehouse and weather systems like Israel's vaunted Iron Dome or the U.S.-supplied THAAD air defense really held up under the pressure of a high-intensity missile barrage. This is part technical breakdown, part strategic context, and we'll try to explain it in language that is engaging whether you're into weapons tech or just curious about what happened on the battlefield. Let's set the stage first. In June 2025, Iran launched one of the most extensive aerial missile and drone attacks on Israeli territory in decades, firing hundreds of ballistic missiles and unmanned aerial vehicles at strategic and urban targets across the country. Israel has long relied on what's often described as one of the world's most sophisticated multi-layered air defense architectures, designed to protect its airspace from everything from cheap unguided rockets to high-speed ballistic threats. Wikipedia, at the lowest tier, is the Iron Dome system, developed by Rafael Advanced Defense Systems and Israel Aerospace Industries. Iron Dome is engineered primarily to detect, track, and intercept short-range rockets and artillery shells, the sorts of threats that groups like Hamas and Hezbollah have historically employed from Gaza and Lebanon. It combines radar, fire control, and interceptor missiles to evaluate which incoming projectiles pose a danger to populated areas and only engage those to avoid wasting expensive interceptors on harmless trajectories. The Washington Post, +1. Above that, systems like David's sling and arrow to arrow 3-handle, MEDIUM, and long-range threats, ballistic missiles, and cruise missiles that fly farther, faster, and with more complex flight profiles. Arrow 3, in particular, is designed to perform exoatmospheric intercepts. That means hitting incoming missiles high above the atmosphere before they descend toward their target. The Washington Post, across the Atlantic, the U.S. supplies its own advanced interceptors, including VAD terminal, high-altitude area defense. THAAD is intended to destroy short to intermediate-range ballistic missiles during their terminal phase using a high-precision, hit-to-kill approach, essentially slamming an interceptor into the incoming warhead to neutralize it without an explosive payload. This differs from systems like Iron Dome's Tamir missiles, which use small warheads to fragment a target in flight. Press TV. Now enter the controversy that's been circulating online and in state media. Iranian military officials have claimed that one of their THAAD hypersonic missiles, reportedly capable of flying at Mach 13 to 15 and maneuvering in flight, not only evaded Israel's best defenses but penetrated the window of a senior Israeli intelligence official's office and caused structural damage. According to Iran's Brigadier General Abolfazl Shekarki, this event demonstrated both precision capability and the limits of advanced defensive shields like THAAD. Press TV +1. On the surface, it's a stunning claim, a high-speed missile slipping past layers of interceptors and striking a hardened or sensitive building. For a viewer or listener, that sounds dramatic, almost like something out of a techno-thriller. But for a defense analyst or military engineer, there are several layers to unpack before you conclude that the defense systems failed outright. First, it's important to put Iron Dome's mission and design scope in context. It's highly effective at its intended role, stopping relatively short-range, slowish rockets. And Israel reports up to 86 to 90% interception of incoming ballistic missiles when all systems are working in concert. These figures include Iron Dome, David Sling, Arrow interceptors, and allied contributions. And they represent one of the highest recorded performance rates for layered defense in real conflict scenarios. AJC +1, that said, no defense system, no matter how advanced, is perfect. Interception is always a game of probabilities and timing. Missiles move at incredible speeds, and radar and fire control systems only have seconds to detect, track, and respond. Complex flight profiles, high maneuverability, and countermeasures can all reduce the effectiveness of any given shield. This isn't a flaw unique to Israel. Even the U.S. Patriot system struggled in its early days against Iraqi Scuds in the 1991 Gulf War, which eventually led to significant upgrades and doctrinal changes. Bulgarian Military Industry Review, when it comes to THAAD and similar hit-to-kill systems, their interceptors are expensive and precise, but they are also tuned for specific threat envelopes. If a missile's trajectory, speed, or radar signature doesn't match expected parameters, systems can struggle to engage optimally. Early reports from analysts reviewing recent engagements have noted that some intercept efforts either didn't T-launch in time or couldn't T-lock on quickly enough, leading to a minority of missiles striking their targets. MIRA safety, crucially public claims from either side. Iranian officials praising their own military achievements or Israeli statements about interception rates should be viewed with a degree of skepticism, not because the systems don't work, but because warfare narratives are often shaped by strategic communication goals. One side's precision strike could be another's marginal penetration amid mostly successful defense. Without independent verification, it's difficult to conclusively determine the exact sequence of events behind any individual impact. www.ndtv.com. Another key point is the notion of hypersonic missiles versus traditional ballistic threats. Hypersonic weapons behave differently than standard ballistic trajectories. They can change course mid-flight and fly at lower altitudes for portions of their journey, making them harder to detect early and potentially more resilient to certain types of interceptors. If Iran truly fielded hypersonic variants, it would represent a serious development in offensive missile technology. But as of now, there is limited open-source evidence verifying the operational use of such weapons in combat. Much of the reporting comes from state-linked outlets repeating official claims. Royal News: from a viewer's perspective, it helps to imagine air defense as multiple overlapping nets. Each net, Iron Dome, David's Sling, Arrow, THAAD, is woven for a particular class of incoming threat. A small tear in one net doesn't mean the whole system is useless. It means the overall structure was pushed to its limits. Missile defense is inherently probabilistic, because you're reacting to something moving faster than human response times, with milliseconds to spare. Even with a 90% success rate, tens of missiles out of hundreds can break through, which in a densely populated area still creates headlines and dramatic footage. There's also the cost dynamic. Intercepting a missile often costs magnitudes more than the offensive missile itself. THAAD interceptors can run into the $10 to $12 million range apiece, whereas an Iranian THAAD or other ballistic weapon might cost a fraction of that to produce. That cost asymmetry means that, in a sustained conflict, the defending side could face both tactical and logistical challenges beyond sheer effectiveness percentages. Iranian officials have seized on this point to contrast their lower-cost missiles' performance with expensive Western interceptors. Press TV. It's worth stressing that in the larger campaign, Israel's defense network still intercepted the vast majority of incoming threats, and the attacks, while damaging and disruptive, didn't result in a strategic collapse of protective layers. Most of the missiles that did reach the ground struck open areas or caused limited structural damage compared with what unchecked volleys could have done. AJC: from an engineering and design standpoint, the performance of these systems is a mixture of cutting-edge technology, real-world limitations, and evolving threat profiles. Radar systems must detect tiny objects at long distances, discriminate between decoys and real warheads, and cue interceptors that have only seconds to accelerate and collide with targets. Software, hardware, and human operators all come into play. And that complexity means occasional failures are almost inevitable under intense saturation attacks. In sum, the narrative around system failure and precision strike through a window blends factual elements: Iran's missile launch campaign, the penetration of some defenses, and the existence of advanced interceptor systems with strategic framing from Iranian leadership aimed at boosting domestic and international perceptions of Iranian military prowess. Without independently verified battlefield forensic analysis, it's difficult to separate symbolic claims from objective performance data. Ultimately, what we're seeing in this episode is a real-world stress test of existing air defense technologies under conditions that many engineers and strategists warned could reveal vulnerabilities. It underscores that missile defense is not about achieving perfection, but about reducing damage, buying time, and shaping the adversary's calculus. And as offensive missile technology evolves, including potential hypersonic capabilities, so too must defense systems adapt to meet those threats effectively.